thank you to all of you for being here this evening. I love talking to alumni audiences. You all are incredibly smart and engaged and ask great questions. So what I really want to talk about this evening are issues of water and fire. And I want to do them in the context of climate change and the climate whiplash that at least I feel when one year it's a drought here in California where I live, and then next year it can be flooding people out. In recent years, our real focus has been on drought. And so what I'm showing you here is the most recent for earlier this week, the drought map for the Western United States. And the thing to recognize here is that the warmer the color, the more serious the drought. In this particular day, what we had was something in the nature of about 61% of the entire Western United States in drought, and about 10% in what is known as exceptional drought, which is a drought where you are going to have people finding that they're no longer able to grow their crops, and you're going to find the type of shortages that can deprive cities of water. If you're sort of looking at Oregon there and trying to figure out Oregon, this is what Oregon looked like on November 30th. And what you'll see is that all but 1%, that little piece up there in the Pacific North, all but 1% of Oregon was in drought. And almost a quarter of it was in exceptional drought. That's actually better than about 3 months ago. About 3 months ago, 100% of Oregon was in drought, and over a quarter was in exceptional drought. If you're interested in how this compares to California, California is still in 100% drought, and we have almost 30% of the state in exceptional drought. So this is about as severe of a drought situation as I have seen in decades in the Western United States. And of course, along with the drought has come some of the most massive wildfires we've seen in the Western United States in decades. This is a picture on July 9th of the Bootleg Fire, which, as many of you probably know, is the third worst wildfire in the history of the state of Oregon. But at the same time, we have a drought and we have wildfires. We also can have floods. So again, about a month ago, we had a huge rain event on the western coast. Come back to that in a second. And we had severe flooding in Oregon. Here's a picture from Otis, Oregon, on the Salmon River. This is a photograph from, I believe, November the 12th. And the reason why we can get these types of floods at the same time that we have a severe drought is because of atmospheric rivers. And I don't know about you, but the amount of climate terminology and weather terminology that I know today is like 4 or 5 times what I knew before. There are all these various terms like atmospheric river that I don't remember hearing 3 or 4 years ago. But as probably all of you know today, we get most of our precipitation in the West Coast from these atmospheric rivers, which are long, thin lines of water in the atmosphere that when they hit the coast, sometimes they can contain 20 times the amount of water at the base of the Mississippi River. And in a given year in California, for example, we receive 5 or 6 atmospheric rivers that will bring over 60% of our rainfall. So we can have a year, and this might very well be one of those years, where it's a drought because we don't receive enough of these atmospheric rivers, but we will still receive some atmospheric rivers that can cause those severe storm situations. And we can particularly have that type of a situation when we had what we had on November 11th, which was not only an atmospheric river, but also a bomb cyclone, another term that I don't remember hearing 4 or 5 years ago. A bomb cyclone is basically an atmospheric river where at the time that they make landfall are accompanied by a dramatic drop in atmospheric pressure. In particular, a bomb cyclone is defined as an atmospheric river where the pressure drops 24 millibars in just 24 hours, which is a dramatic drop in pressure. And that's what we had on November 11th. That's what led to the dramatic amount of rainfall all the way from Washington down into northern California. Now, the West has seen worse droughts than we are seeing today. This is a chart that shows the drought severity index for the entire Western United States. So this is not just California or Oregon or Washington. This is in the entire Western United States. And to the degree that the curve is below that mean line, that is a drought situation. And to the degree that it is above it, that's a situation where we have larger than average rainfall. And one of the things that worries those of us who work on water on a regular basis are these two mega droughts. This first mega drought from about 850 to about 1100 AD, and then another one from just a little bit after 1100 to about 1300 AD. And as you can see during those periods of time, we basically had one long continuous drought. That doesn't mean it didn't rain. It doesn't mean there are not years when we had above average rainfall. But what happened during that period of time was that those rainfall periods never made up for the drought periods that preceded them. So the Western United States just got wetter and wetter over time. We know about these mega drought periods in part because there are various lakes in the Western United States where there are forests growing, or that did grow, they're now dead, but did grow in areas which are now underwater. And those could only have taken hold during this type of a mega drought period in which those lakes actually dried up. The other thing that's disturbing, if you actually look at this chart, is that over here, the period that we've experienced in recent times has been a wetter than average period. So one of the concerns is we might actually revert to a norm, which is actually much drier than the norm that we have today. So we've seen droughts in Oregon and elsewhere in the Western United States, obviously for years. We've seen far worse drought. And we've also seen the type of climate whiplash that I said we're suffering today. So this is a picture actually of Sacramento, California in 1862, totally underwater. In December of 1861, January of 1862, it rained so much in Oregon and California that it basically flooded both of the two states. I couldn't find a map of Oregon. Here's a map of California. The white areas that you see were the areas that were totally underwater. So most of the state was flooded. The state became bankrupt because it put out of business virtually all of the major industries at the time, winemaking and cattle grazing. But so this was what things looked like in January of 1862. But by the summer of 1862, we were actually in the middle of one of the worst droughts in recorded history of the United States, the Great Civil War drought of 1862 to 1865. And as you can see with this map in 1863, it extended throughout the United States, and much of the United States, including portions of Oregon, faced severe droughts. So we know things have always been bad, and that sometimes they've even been worse than today. And the problem or the concern is that climate change is going to dominate our future. The key thing to remember about climate change, I'm going to come back to this in a moment, is the one thing that we know for sure with climate change is that temperatures are going to be rising. And just knowing that temperatures are going to be rising is bad news both for water as well as for wildfires. On the water side, though, it doesn't stop just at rising temperature. We also know today that climate change does have an impact on precipitation. This is a picture, for those of you who remember back to 2014, of what some people called back then the ridiculously resilient ridge, which was a high pressure ridge which basically settled down and wouldn't move off of the coast of the Pacific Northwest. And as a result of that, we had, again, one of the most severe droughts in the history of the Western United States. Climate scientists looking at the ridiculously resilient ridge now estimated is probably sometimes like something in the nature of 3 to 5 times more likely that we will have this type of unusual high pressure ridge off of the West Coast than it was before. We also know that climate change will lead to worse droughts. Now, there are a lot of maps that you can find on the internet or by going and looking at scientific journals of what's going to happen to precipitation under climate change. And I've inserted one on the right-hand side of the screen here. And you can see that this particular model suggests that, for example, Oregon, during the winter probably is likely to be wetter, but during the summer, and I'm sorry, just have to go back there. During the summer, it will be much drier than today. I personally don't believe any of these maps. The climate science is, in my view, simply not good enough to really predict for sure whether on average we're going to have more precipitation or less precipitation. But what we do know is that no matter what the precipitation, we're going to have more extremes, and those extremes are going to be more extreme. So we will have more droughts, we will have more flood periods. And our droughts will be worse than they've been in the past, and the floods will be worse than they have been in the past. So we don't necessarily know what's going to happen in the mean, but we know, again, that the extremes will be more frequent, and those extremes will be worse than they are today. The other thing, and this gets back to my point, that the one thing that we know for sure under climate change is the temperature will increase, is that what we are now encountering is something that we have named hot droughts. If you look over the last 100 years at droughts, one of the things you'll find is that in 50% of the droughts, the temperature was actually below normal. And the other 50% of the droughts, the temperature was above normal. In other words, there was no correlation between whether or not you had high temperatures and a drought. But what we know is, based on all the climate science that has been done, is that in the future, when we have a drought, that drought is going to be warmer than average. And that's a hot drought. And a hot drought has a variety of implications. The first is we rely upon, in the Western United States, most of the Western United States, we rely upon our mountains and the snowpacks on those mountains as a form of a natural reservoir. What I'm showing you here is the Sierra Mountains of California. And in California, the Sierras are incredibly important because it snows in the winter, that snow sits there, and then it begins to melt in the spring and the early summer. We're able to capture the water at that period of time and use it during periods when we otherwise don't have precipitation. The problem with warmer temperatures is even if we get the same amount of precipitation as before, that precipitation will be more likely to take the form of rain than snow. And here are 2 years adjacent to each other. 2019 was a relatively normal year in California in terms of temperature and precipitation. And you can see we have a huge snowpack. February of last year was not an abnormal year in terms of precipitation, but a very warm year. And so as you can see here, we had virtually no snowpack. And if you look throughout the Western United States, including the mountains in Oregon, what we are finding is that the spring snowpack, that snowpack as of late March and early April that we depend upon for water supply has been declining. In this particular chart, you can see the decline since 1969. With the blue lines above the line showing above average snowpack, red lines below average snowpack. But we also know that this has been occurring since at least about 1950. So we're losing our snowpack. So that's one consequence of having a hot drought. Another consequence of having a hot drought is that you have high evaporative demand, right? So you realize when temperature goes up, that evapotranspiration is going to go up also. That the plants are going to require more water than in a cooler year, and that more water is going to evaporate. So this means that even again, if you have the same precipitation levels as before, the plants will require more of that water. You'll have more of that water absorbed by the soil, and you will have more of that water evaporate before that water ever reaches a river or stream. And this is a problem that we have right now with the Colorado River. This is a picture of Lake Mead. You've probably seen pictures like this before with the bathtub ring going around. That's because Lake Mead is now at only a fraction of the water that was in Lake Mead 20 years ago. And the reason is not only because we have had less precipitation in the Colorado River region, but also because the Colorado River region has been warmer than it was before. So, for example, this year, the best estimate I saw was that you had precipitation down by about 10%, but you had the actual amount of water reaching the river down by about 30%. So that 10% was lower precipitation. The rest of it was, again, because of the warmer temperatures. Now, this has a severe impact on all of us. It means if we're farmers, we might not be able to grow as many crops as we otherwise would. We might not be able to grow anything. If we're trying to generate hydropower, we're going to not be able to generate as much hydropower. If we're in a city, we might have to water ration. But I'll tell you right now that of all of the users of water, the user of water that suffers the most in a period of drought is the environment. That's because of the fact that in every state in the West that I know of, we prioritize, and that might be correct, but we prioritize people and we prioritize the economy. And so when we have a drought situation where we tend to focus initially is in reducing the amount of environmental water. That's not always the case. When that's not the case, that's where we generate controversies. But in most cases, it comes out of the environment. And I couldn't find an equivalent of this for Oregon, but I have a good friend in California who has for the last 50 years been conducting fish surveys in California. Particularly looks at the status of California native fish species. And if you look at the 1975 survey, which is on the left-hand side of this chart, what you'll see is that at that point in time, over half of our native fish species were relatively stable. In other words, they were doing fine. We did have some that were extinct. We had some that were listed under the Endangered Species Act. About a third of all species were vulnerable. Compare that to the most recent survey that he did, which was in 2010, when rather than having over half of the native species in California relatively stable, only 17% of those species were stable. And a number of those species have since slipped into the vulnerable category. This, at least to me, is the best evidence of the problems that the environment faces as a result of climate change and drought. But climate, of course, is also contributing to the wildfires that we see today. These are two charts that NOAA put together. The chart at the top, starting in 1963, shows the number of fires in the Western United States. As you can see here, we've seen a dramatic increase in the number of fires in the Western United States starting in about the year 2000. But the more important chart is the one at the bottom, because the number of fires doesn't matter. The question is, what's the intensity of those fires and how many acres do those fires burn? And the chart at the bottom is of megafires. So those are the fires that burn hundreds and thousands of acres. And you can see there, in many ways, an even more dramatic increase in the number of those megafires over the last 50 years. Now, I just want to pause here to, of course, emphasize that climate is not the only cause of the wildfires that we're facing today. We've also suppressed fires in our forests over decades, and that has left a lot of fuel for fires today. Where fires have occurred, we have frequently let invasive grasses grow up in the areas where the forest used to be. That's another form of tinder for those fires. We've increased the wildland-urban interface. So we have let people build right in the middle of those forests, which of course increases the damage that occurs when we do have fires. And in California, one of our concerns is that we have a lot of above-ground electricity infrastructure, which has been one of the most frequent causes of fires. So again, climate is not the only cause, but climate is certainly contributing to the increase in the number of wildfires and the increase in their intensity. And this is a chart, again, from NOAA that looks at various climate models and asks, okay, in the future, how much more likely do we think wildfires will be in the face of climate change? And as you can see here, Oregon is one of the states that it looks like there will be fairly significant increases in the number of weeks with large wildfire risk. So I always like to focus on what do we do about all of this, right? I mean, it's one thing to talk about all the various problems that we face, but what can we do about it? And so I want to talk about four, what I think of as important solution sets. First, looking to nature for some of our solutions. Second of all, looking to see whether or not we can improve the situation with new technologies. I happen to be a technological optimist. The third is using market incentives to try to change behavior in a way which is beneficial. And then the final thing is to collaborate, is to get together across sectors, across political divides, and look for solutions to problems. So I want to talk about each of those very briefly. So the first is nature-based solutions. If we want to deal with reduced rainfall, increased drought as a result of climate change, one of the things that we know we can be doing is protecting our watersheds, because those watersheds are a resilient means of dealing with reduced water availability. And Oregon has actually done a wonderful job of protecting most of its headwaters, most of its watersheds. That's not been true of much of the United States or much of the world. It's not even true of all of Oregon. The Nature Conservancy, recognizing this, has created a variety of water funds, fondos de agua. And the idea behind these water funds is that the cities that receive their water from these watersheds benefit from protecting those watersheds. And so one of the things those cities should be doing is paying the people who live in those watersheds to protect the benefits of having a healthy watershed. So this just sort of shows the way in which these water funds the Nature Conservancy has been setting up operate. So you have a city, it receives benefits from a healthy watershed upstream. So what it does is it imposes some type of fee on its water users, and then it uses that money to pay the upstream community to be more effective stewards of the watershed and the services that are received. And in return, those watershed services, which could be healthy forests, which help to provide clean water, to reduce flood risks, to permit better recharge of upper aquifers, all of those are benefits that those cities receive. So that's one example of a nature-based solution. The idea of a water fund in which a city actually will pay the people who live in the watershed to preserve those watersheds for the services that they receive. Another example from Oregon is floodplain restoration. For years, as many of you know, one of the things that the Army Corps of Engineers loved to do more than anything else was to straighten rivers and try to get rivers to run in narrow passageways. If we want to reduce the type of floods that we can expect in the future with more extreme flood situations, we want to restore those floodplains. And again, Oregon has done a great job. This is actually a picture of the Foster floodplain that Portland has restored. At Stanford, we've actually started something called the Natural Capital Project, which is run by Gretchen Daly. It's a joint venture between us, the Nature Conservancy, WWF, and the University of Minnesota. What the Natural Capital Project is doing is it's evaluating what are these nature-based solutions. And it's then developing tools that we can use to identify where should we be trying to restore floodplains. What areas should we be protecting in watersheds? And then also provides an economic valuation of that so that politicians know that actually the economic value of going to a watershed and restoring it, which you would hope that people would want to do because it's a good thing to do for the environment, it's actually a good thing to do for the economy also, and justifies whatever payment is necessary to preserve that natural capital. So that's the first thing, right? We want to get in there and we want to look for the natural solutions. The other thing that I think is incredibly important is to look for new technological solutions. This is a picture of Intel's Ronler Acres campus, where probably many of you know Intel now has the largest industrial recycling facility in the world. They have now recycled over 1 billion gallons of water for reuse within that particular Intel facility. And that's great. That's a use of technology to reduce the water footprint that Intel has. But we need to go much farther, in my view, on recycling and reusing water than we are today. Oregon and California already recycle a lot of water, but we're behind a variety of other areas like Singapore. Singapore, probably some of you have heard, now produces new water. So this is recycled water, which is potable. You can drink it. And if you go to the visitor center next time you're in Singapore, you can actually get a bottle of new water to drink. In the future, my guess is within 10 years, we will find a lot more potable use of recycled water. To do that, though, we have to reduce the cost of recycled water. Recycled water is still relatively expensive. And so engineers at Stanford are working at something called the Codago Resource Recovery Center to reduce the energy costs and to reduce the overall cost of recycling water. One of the ways they're doing this is that they are looking for ways of taking the energy which is actually embedded in wastewater. And if you think about wastewater, it has a lot of embedded energy. If you've ever been near a pond of wastewater, you can smell the gases coming off of that wastewater. That is all embedded energy that can be burned for power. And so the Codago Resource Recovery Center, they're actually testing technology that maximizes the energy produced from their recycling facility. And at least at a small scale, they've gone to a point where they can produce more energy than it takes to recycle the water. So they can both recycle water, so you have new water that you can distribute, but you also have additional energy that you can utilize or sell. So we need to be thinking about those types of technologies so that in this particular case, we can recycle more water. Another example of new technology, and you'll see I'm a technology wonk, even though I'm a lawyer, I love all of this stuff. One of the major problems in virtually all cities of the world is that we have massive leaks. We lose a lot of water to leaks in our pipe mains. And so one of the things we need to do is to detect where those leaks are and address those leaks before they get overly bad. Xylem, which is a water technology company, has come up with this little device called a smart ball. And you can see the smart ball in its launcher over there on the left-hand side. And basically what they do is they launch the smart ball into a water pipe, as you can see there on the right. And it basically is free floating and it can direct itself as to where it wants to go. And as it's going along, it basically measures acoustically the condition of the pipe. And then using artificial intelligence, can detect where leaks are beginning and how bad those leaks are. And it can then tell the water utility where it needs to go in and fix leaks before those leaks become overly bad. We also have technological approaches to fires. So here's a picture of two homes. And the one on the left is sort of a typical home that you might find in a forest. The one on the right has been fire hardened. It's been fire hardened by having cement sidings, by having a metal roof, by having dual paned and tempered screens on the window, and having increased joint space underneath the front porch. And in both of these cases, this is in a laboratory. They're shooting fire at the two homes, and you can see the difference in the effects. So again, another technological approach. One concern I have, though, is that we're not doing enough to really get these technologies developed and then adopted. I did a study about 5 years ago. This is from that study. What this shows is the number of new patents. In the blue line is new patents for clean energy technology. The green line is new patents for water purification technology. And what's interesting is the water purification patents were always less than the energy. But look what happens about 2005. At that point in time, we adopted a variety of new policies in the United States to encourage the development of clean energy, and you see a dramatic increase in the number of patents being issued. Whereas on the water purification side, that gets basically flatlined. We need the same type of policies that we have in the energy area adopted in the water field in order to encourage the development and adoption of new water technology. Market incentives. I'll try and get through this relatively quickly, but just as in the energy area, we need market incentives to encourage conservation and the wise use of water. What you see on the left-hand side here is actually a smart water meter. Smart water meters are being adopted more and more around the United States. They have a whole variety of benefits. One of them is they can actually let the homeowners see how much water they're using at every hour. And if you think about it, that can be really beneficial, because if you see you're using a lot of water at 2 a.m. in the morning, that probably means you have a leak somewhere in the house. So it's a really fast way of determining whether or not we have a leak. But the other thing is that we need to charge people for water in a way that reflects how valuable water actually is. One of the things I always like to point out to people is that we do not charge people for water. You are not charged for water. You are charged for having somebody purify the water and then deliver the water to your house. But you're not charged for the water itself, even though water is an extremely precious resource. And it imposes a cost on the environment of taking the water out of the river and stream. So we actually need to price water properly. Water markets can also be really valuable as the supply of water declines. The map in the lower right shows the emerging water markets that we have in the Western United States, where somebody who needs more water can purchase water from somebody who, for example, can conserve water, gives that second person an incentive to conserve, and ensures that our greatest needs for water are met. The chart up here on the left shows sort of the major players in the water market. And the upper line here is who's buying water, down here is who's selling water. The thing that's most interesting to note here is that 26% of all the water bought on water markets today in the Western United States are bought by environmental groups. Environmental groups who believe that we do not have sufficient water in our rivers and streams, and that rather than trying to force people to put more water back in the river, maybe it's a wise idea to go and buy some of that water and use it to put it back in the river. Oregon had the first water trust in the United States, a nonprofit organization specifically designed to go out and buy water and put it back into a river or stream. I'm now involved with an impact investment fund called SWIFT, the Sustainable Water Impact Fund, a joint venture of the Nature Conservancy and a private organization called RRG Capital Management. What we're now doing is we're actually buying water and land in the Western United States, in Australia, and in South America. We're then managing the land and the water in a way to increase the productive benefit of that water. But we're also putting some of that water back into rivers and streams in order to improve the environment. So here's an opportunity of actually using investment capital to improve the environment. And we can also use markets to address wildfire. The Nature Conservancy is now working with a variety of insurance companies to see whether or not they can come up with an idea for what they call wildfire resilience insurance. The idea here is that if you're a small town in the middle of a forest in Oregon or California, we know that you could construct a fire break around your town that during most periods could serve as a local park, picnic area for local citizens, but could also, again, serve as a fire break to help protect that town against fire. The question is, though, who's going to pay for putting in that fire break? And what we're looking at, the Nature Conservancy, is the possibility of getting insurance companies to themselves invest in those fire breaks, or to reduce the insurance premium for cities or towns that have put in those types of fire breaks. So using insurance as a mechanism for encouraging towns to take the type of steps that they should take to protect their citizens against wildfires. So the final thing I'll just quickly touch on is the idea of collaboration. To solve a lot of the problems that we're going to face in the face of climate change, we need to engage in greater collaboration. I just want to give you two examples. When Steve introduced me, noted that I used to head the Woods Institute for the Environment at Stanford. One of the things we created there was the idea of an uncommon dialogue. The idea was to bring together people from different perspectives, along with academics, to try to solve some of the most serious issues that we face. One uncommon dialogue that we conducted about 2 years ago was between environmental groups on the one hand and the US hydropower industry on the other. One of the things environmental groups are trying to do is to remove old, obsolete dams that don't benefit anyone. The problem is it's really expensive to remove old, obsolete dams. So working with the hydropower industry, what we came up with was an idea to go to Congress and ask Congress for money that could be used to do three things. Number one, remove old, obsolete dams. That was what the environmental groups wanted. Second of all, to retrofit older hydropower dams to have, for example, fish passages, again, to improve the environment. But three, to also be able to rehabilitate old hydropower dams, which are declining in safety. And that was something that the hydropower industry wanted. So joining forces with the hydropower industry, we had a very powerful coalition that we were able to go to Congress with. And in the most recent infrastructure bill, we have about $1 billion for removing old dams, $1 billion for retrofitting old dams, and $1 billion for rehabilitating old dams. We also, and this is my last example, have launched in the San Joaquin Valley of California a water collaborative. And this brings together the farmers, the environmentalists, the environmental justice groups, and cities. San Joaquin Valley of California faces probably the most severe water constraint of any area today in the Western United States. And for years, all of those interest groups have been warring. We sat them all down over the course of the last year, and a week ago, they all signed on to a common statement of problems and solutions, which we will now go into better defining and implementing. I never thought I would see all these groups come together around joint solutions. But the idea was everyone listened to each other and tried to figure out ways in which they could advance their interests while at the same time advancing somebody else's interests. So for example, in the San Joaquin Valley, we know for sure some farms will go out of business. We just don't have enough water today to support all of the various farms. But the environmental groups came up with a fund to help buy farmers who need to go out of business. And then they will restore what we call rewild those farms for environmental purposes. So again, collaboration is incredibly important. So at that point, I will just close with this picture. This is a picture of the Colorado River in Mexico, which for 40 years had no water in it. And we were able to put together through a collaborative process an agreement with Mexico, where about 5 years ago, we released water down the Colorado River, designed primarily to try to restore some of the riparian habitat. But what I love about this picture is here are these cowboys who've come out with their horses to basically play in the water. And to me, it shows the importance of water, not only for health, for the economy, for the environment, but for our spirits.